Okay, so let's look at FRQ number 3. FRQ number 3 says that a container has a shape of an open right circular cone, which they gave us the shape down here. So that was nice, as shown in the figure below. The height of the container is 10 centimeters, and the diameter of the opening is 10, which they've also labeled for us. Water in the container is evaporating so that the depth H, so H is what's changing, at the constant rate of -3/10 centimeters per hour. So changing means dH over dt is -3/10 centimeters per hour. And we are looking at volume. If you look down later, it says specifically volume. So your volume formula, oh, I'm sorry about my computer. Your volume formula is 1/3 pi r squared h. And we know that we're going to have to be taking the derivative of this. And we have to be careful because taking the derivative of this, we have r and h. We need to pick one. And we know that we're given dh, so we know that we want r in terms of h. So we need to figure out how we can write r equals such that it has h inside of it. And what we do is we look at our ratios. So r and h are proportional. So this little r and h would be the same as this big R and the h that they've already given us. And we can figure out the radius because they gave us the diameter, and radius is just the diameter divided by 2. So our radius is 5. So what we know from the given, they gave us that our radius of 5 is proportional to a height of 10. So that will be the same for any radius and diameter. So we will have a radius and height, I'm sorry. So 5/10 is the same as any radius to height. So we know that we want r in terms of h, so we want to solve for h. So let's get these out of the denominator first. Let's multiply both sides by 10 and then both sides by h. So those will cancel out these 10s and these h's. So we have 5h equals 10r. And we want r equals in terms of h, so we divide by 10. And r, 5 and 10 can cancel. We have 2 on the bottom, so that's h over 2. So we can use this, and we will have only h there, so that is what we can do. We can't do it if we have too many variables in there, we can't take the derivative. So, oops, not the derivative, just our regular volume. Volume is equal to 1/3 pi. Instead of r, we now have h over 2 times h. Simplify that out. These two are both in the bottom, so we will have, and this is squared. So we have to square that first, order of operations. So our volume is 1/3 pi h squared over 4 times h. And now we will combine those denominators. We'll multiply, so we'll have 1/12 pi h squared times h is h cubed. So here's our volume with just one variable, which is what we need and want. So let's look at part A. Part A says find the volume, so we'll use volume in the container when the height is 5. So here's our volume, 1/12 pi. Our height is 5, so we're going to plug in 5, and we will cube it. So here we have 1/12 pi. 5 times 5 times 5 is 125. So our volume is 125/12. You can put pi out to the side or write it up with 125. It doesn't matter. 125 pi/12 is our volume. And don't forget to indicate units of measure. So we are talking about centimeters, so a volume would be centimeters cubed. And that is our answer to part A. We didn't even have to take a derivative. Part B, find the rate of change of the volume. So part B is asking you for dV, dV, dt. with respect to time, that's what our dt is for, when the height is 5. So we are still using a height of 5. So we need to take our volume. Our volume is v equals 1 over 12 pi h cubed, and take our derivative to get dv dt. So dv dt is 1 over 12 is a number, pi is a number, so we're just taking the derivative of h. So the 3 comes down, and we have 3 over 12 pi h, and then minus 1 is squared. And then we took the derivative of h, so we need dh over dt. So dv dt is equal to 1/4 pi h squared dh dt. To find dv dt, we need h, and we need dh dt. H they gave us as 5, and if we go back up to the top, they gave us dh dt, which is negative 3 over 10. So let's plug all this in and get our answer. dv, oh, sorry for my computer. So we're going to plug this in. So dv dt is 1/4 pi. Height is 5, they told us. And earlier they told us dh dt is negative 3 over 10. So when we multiply all this together, we are going to square, oh, and 5 is squared. So dv dt is 1/4 times pi times 25 times negative 3 over 10. So what's on the bottom can be combined, and what's on the top can be combined. So dv dt is 1 times pi times 25 times negative 3, which is negative 75 pi, over 4 times 10 is 40. You can reduce this if you want. 5 goes into both of these, but it's not necessary. We do need units, though. Remember, we're looking at volume over time. So our volume, we already figured out what those units are when we did our volume. Volume is centimeter cubed. This computer is the worst. Centimeters cubed. And we need time. So we have to go all the way back up to the top to figure out what time was. Time is hours. So this is centimeters cubed per hour. That's your final answer. If you want to simplify it, you can again. And honestly, for an FRQ, all they're looking for is this. So if you had stopped here and put your units here, that would have been an acceptable, correct answer for the FRQ.